Hi, in this tutorial, I'll show you how you can build 10 different and cool Instagram filters. We'll start off by creating effects like the warm filter and the cool filter. And then we'll move on to some interesting filters like the Gotham filter and the Sepia filter. Then we'll also cover filters like the pencil sketch filter and the detail enhancing filters. And we'll also go over filters like the Stylization filter and the Invert filters and some others. And at the end, I'll also show you how to combine all of these filters and create final application that works on your webcam in real time. And you can select individual filters and it will be applied in real time on your webcam feed. So this will be a pretty good application. So this will be a very exciting tutorial that will teach you a bunch of techniques in order to create all of these amazing filters. So stay tuned and watch the full tutorial and let's get started. So this will be the Jupyter notebook that we'll be using today to create those filters. Make sure to download all of this from the link in the description below. You'll get this documented notebook along with any other required files to run this. So let's get started. So to start off, we will be again building these amazing 10 filters. So we're going to build up from the concepts that we learned in the previous two parts. This is the third part. Even if you haven't watched those videos, the only thing connected to those videos specifically is I think the warm filter, the cold filter, the Gotham filter and the Sepia filters. The other remaining 6 filters are something that we'll just introduce in this tutorial. So you're covered if you're just interested in this 6, but I would strongly recommend to get the full overview of how lookup tables work, how mouse clicks work. In order to learn that, just watch the remaining 2 parts of this Instagram series. It's really exciting and you'll learn a lot of other things while you're watching those tutorials. Anyways, to start off, we'll import the libraries that we'll be using. So we'll be primarily be working with the OpenCV library, so we'll import that. And I'm also importing the Pygame library, and this is just for a simple sound click of taking an image, which I'll just play at the final application. It's not necessary. And we'll also be using NumPy because there's a lot of matrix manipulations and some other functions. And this is the function that I'll be using to create some lookup tables. And it's a SciPy interpolation function. I'll later on explain, but I think we've covered some interpolation techniques in the past tutorial. So, and that one I'll be using to display the images in the notebook. So that is all that we'll be needing. And let's start off by this filter, creating this warm filter effect. This is a very popular filter, which what it does is that it enhances the red channels of the image, and then it also reduces the all the blue in the image. So ultimately, it looks something like it gives a warm effect on the final image, and it's a really exciting effect. Something like this, and I'll show you some examples of what it does exactly. And so yeah, let me just first run this one, and once I've ran this and show you some examples, I'll explain how this is working. So as you can see, this is the input image, and once we apply the warm filter effect, it looks like this. And let's take a look at another example, input image, and once you apply a warm filter effect, it looks like this. So this looks like it was taken on a cloudy scene. But this one looks like it was taken when there was sun on top of the person. So completely changes the whole scenario, right? So something this is really exciting. You can completely change the whole scenario or the setting in which the image was taken. And yeah, so here's how this works. The intention is again twofold. We need to enhance the red channels of the image, and we need to reduce the all the blue channels in the image. So we'll need to create 2 lookup tables. One lookup table is responsible for enhancing or increasing the redness in the image, and the other one is responsible for decreasing the blue, the blue in the image, right? So this is the table that I'll create. Now, what this function exactly does, it interpolates between 2 sets of variables and creates an array. of the defined length. So the length of this array will be range 256, it will be an array from 0 to 255. Now this is the length of this array. Now this is how the interpolation will be done. So I'm telling it that I need you to create an array of 255, and this is how I want the transformation to be. So what this is exactly doing, it's creating a mapping array, a lookup table basically, that maps values from 0 to 264 to 0 to 75. So I'm nudging it towards the higher end. So this table will be used to increase the red channel of the image. Again, from 64 to 128, so the values in the red channel that are from 64 to 128, I want you to transform it to the range of 75 to 155. So again, as you notice, I'm nudging a bit to the higher end all the values. And then obviously at the end we have 255 because the color pixels starts from 0 black and all the way to 255. So this is the end. Now as you can see, at each range I'm nudging it towards the higher end. Now this table will be called the increase table. It will be responsible for interpolating the red pixels in the image and moving it towards the higher end. Similarly, I'll do the exact opposite for the blue channel, and I'll call this one the decrease table. And this time what I want is I will give the pixel values from 0 to 64, and I want to reduce these values. So values from 0 to 64 will be reduced to 0 to 45, and then similarly 64 to 128 will be reduced to 45 to 95. So this is what this does, it reduces the pixel values and nudges it towards the lower end of the pixel values. So this is what's happening. And again, this is an interpolation function. For example, if I if the pixel value of if the original pixel value has a value of 64, then it will be converted to 45. Similarly, if the value is between 0 to 64, then it will be converted to something in between 0 to 45. And if you do this for all the pixel values in the image, you'll find all the blue in the image reduces. Similarly, if I do use this lookup table for the red channel, you will find that all the red in the image increases a bit. So by creating these two lookup tables, and I'm just visualizing some 10 values from this lookup table here, so you can actually see what's going on. So this is the lookup table that we have created, and yeah, so this is what this looks like. And now I've created a function called apply warm. Now this is the function which I'll pass in the image and set display to true, which means just show me the map, use matplotlib to display the results. So this is what this exactly does. And then it will take an image and then it will split it into its three channels. It's a BGR image, right? Instead of RGB, OpenCV works with BGR. We have a blue channel, green channel, red channel. After splitting these three channels, I'll change the red channel. Intention is to use the increase lookup table which we created earlier, and enhance or increase the redness in the image, right? So this is the formula for that. cv.lookup table, I use the lookup table which I have here, and then I pass in the channel that needs to be changed, and then the data type would be unsigned it. This is the type you need, and then we get the output red channel which has values increased towards the higher end using this increased lookup table. Similarly, we'll do the same but use the decrease table for the blue channel. And after we have converted or manipulated the red channel and the blue channel, we'll merge back all three channels. As you can see here, I have not touched the green channel, because when you're applying the warm filter, you don't need to work with the green channel. You just manipulate and change the blue channel and the red channel. But if you're interested, just as an experiment, you can try to change the green channel, maybe increase or decrease it, and see what sort of effect the final image looks like. So after I've changed the red channel and the blue channel, I'll merge back all three channels and get this output image back. And this is the result and the final image that I'm displaying along with the original image, so you can better visualize all the results. So again, these are the results. Pretty interesting how just with by the way, if you don't understand how lookup tables work, the intuition behind it, I would strongly again recommend watch the previous tutorial where I explained in detail what lookup tables are, how they work. Alright, so this was the warm filter. Now I'll do the exact opposite now. This time I'll create a cold filter like effect. Now this is the effect like an effect like this. Now this looks like the scene or the image was taken in a very cloudy scene. There was no sun, and again a very interesting effect. And all you need to do, if you just understood what I just explained here, is just reverse what I've said. Instead of decreasing the blue channel, increase it, and instead of increasing the red channel, decrease it. That's all you need to do. So in this function, I'll create a function apply cold, pass in the image, and this time I'll use the decrease table for the red channel, so to decrease the red values, and you use the increase table for the blue channel to increase the blue values. And that's all I'm changing here. All the code is same. The only difference here is that I'm just swapping the channels. So that is all I need to do, and I've initialized this function. Now let's test it out on some images. So this was an image, and this is the output image. Not the best representation of this filter on this image, but let's test it out on another image. Now this is a very exciting effect, I think. So you take this image, which was taken on a standard normal day, and then you transform it to something like this, which was taken on a very cloudy day, or some winter or cold like effects. So you can mess around with these interpolation values to maybe give more warmth or more cold to the final effect. So you can maybe nudge these values towards, you can make it 85, or you can make, instead of 155, you can do 165 and see the changes. So it would be really exciting as an experiment to see how warm you can get without making the image look totally unoriginal, or manipulated or distorted. Yeah, so we've already gone over two exciting filters, the warm filter and the cold filter. And as I will say, these two filters are heavily utilized by many users in Instagram. Now let's move on to one more interesting filter called the Gotham filter. Now this is a bit more involved than the warm filter and the cold filter. It will you do this, we'll have to do three different steps, and this will be this. To apply the Gotham filter correctly, you will need a more fine grained control over how you manipulate the pixel values and where you nudge, how you nudge it towards the higher end or towards the lower end, and which part of the whole array you nudge it. So to create the Gotham effect, so the Gotham effect sort of looks like this. This I think the best way to describe this sort of a filter is, for me, is to it gives it sort of like a cinematic effect to the whole image and makes it look a lot cooler than what it originally was. So I think this is how I would probably describe it, but you can have your own definition of what this filter effectively does at the end, right? So anyways, to apply the Gotham filter, you need to do three things. You need to increase the mid-tone contrast of the red channel. So we'll nudge only the mid section of the red channel towards the higher end, and then we'll manipulate the lower mid values of the blue channel towards the higher end, and then decrease the upper mid values of the blue channel. So we'll push it towards the lower end. And I'll show exactly what this means. So this is what I mean by my statements above. So this is responsible for increasing the mid contrast increase. So as you can see here, I'm decreasing the lower end values up till 128, which is sort of like the midway. I'm decreasing the value. So 25 becomes 13, 51 becomes 25, 76 becomes 51, 102 becomes 676. And remember, all the values in between are interpolated the same way. For example, the value between 0 to 25, for example, like 12 would be something like 6 if you interpolate between the mid of these two ranges. Anyways, just to get back on track, up till from start to mid, we're decreasing the values, and then from mid to all the way to the end, we're sort of like increasing the values. So 153 becomes 178, 178 becomes 204, 204 becomes 229, 229 becomes 242. So as you can see, this is what I mean, the mid-tone contrast increase. We decrease the lower end values and increase the upper end values. So this gives that sort of contrast effect, and we'll specifically apply it to the red channel in the image. Then what we need to do is lower mids increase. So this is what we'll do. Just we'll take the lower values and just nudge it towards the higher end of it. 16 becomes 18, 32 becomes 35, 48 becomes 64, and so on till 128. And then after that, because this is specifically says lower mids increase, we're not concerned with the higher end values. So we'll just ignore all of the above values and just, as you can see, all the remaining higher end values remain the same. We're not changing those. Then we have another step, which is upper mids decrease. So here what we'll do is that we'll not touch the lower to the mid values, but what we'll do is that we'll decrease the upper values a bit. So this is what's happening here. 143 becomes 140, 159 becomes 148. So as you can see, the change is very, very minimal. Maybe you can nudge it more towards the down and see the changes, but all to create a good looking Gotham effect, we make these minute decreases at each point, and this is how, and you see the final result looks pretty good. Again, you can experiment with all of these ranges and see, create novel effects that haven't been done before. Anyways, so we're decreasing very slightly the upper mid values of this range, and as you can see here, and after these three lookup tables are created, our job is done. All we need to do is just do this. What's saying? Apply the increase midtone table lookup table to the red channel once, and apply these two tables to the blue channel. Once we'll apply this table to the blue channel, then we'll apply this table to the blue channel. So now that we have created these three lookup tables, we'll create the apply Gotham function, and inside this function we'll split the image into its three channels. We'll take the red channel and apply the midtone contrast increase lookup table to it, and then we'll take the blue channel, and for the first time we'll apply the lower mids increase, and then for the second time we'll apply the upper mids increase lookup table to it. And finally, when this is done, we'll merge back all three channels and display the results. So let's check it out how the result looks like. So this is the input image and this is the output image, and it's looked pretty good from as compared to the original. It's looked a lot more like sort of cinematic. That's how I put it. Again, I think if you ask me which image looks much pleasing to the eye, I would probably say this one, and this is how the Gotham effect looks like. So now you know how, you may have seen Instagram does it, you may have seen some Photoshop filters, but now you know internally in code what actually is happening at the lowest possible level, how exactly we're changing the channel in slight minute ways to create this exact effect. And now you can go about it and create your own original filters if you want, and discover some exciting effects. Anyways, now moving on from lookup tables to the most basic filter that you can think of using OpenCV. It's the grayscale effect. You just take a color image and convert it into grayscale or black and white. So we take a 3-channel image, an image that contains blue, green, red channels, and then reduce it to a single channel array. So that's how you create the grayscale image. Now you can do this manually by just taking the average, but from what I remember, you don't necessarily take the exact average. There is a formula in how OpenCV does it. So you can do this with NumPy if you want, but another way to go about it is just to use the function that OpenCV gives you, cv2.convertColor, which converts from one color channel to the one color format to the other one, and you just pass in this flag color BGR to gray, and this will take a color image and just convert it into grayscale. That is it. In just single line of code, you created this sort of a filter, and I can just here what I'm doing here is just I'm converting this single array image to 3 channels just for display purposes. It's not necessary, but if you want to save images, this is just one way to do it. You can add extra channels, and again there are multiple ways to make this single channel array a 3-channel one. I'm just doing it for display purposes so that I don't have to necessarily adjust the code here. I can just like pass it cmap equals to gray and something like that, and it would like work fine. And I'll just include the gray channel image here, and it will be displayed like pretty much. Okay, so now I'll just run this, and let's see the results. Now looks nice. So in a lot of cases, people may prefer like converting an image to a grayscale to like it, you might see many people do that. And if you have like more advanced skills in image processing and computer vision, a very exciting effect is to change all the background to grayscale and make the subject of the image in color. So you can do this by using image segmentation techniques, where you segment the person and retain its original color and change the background to like grayscale effect. And I've actually done this in a tutorial of mine. It's called like building 4 applications with image segmentation, something like that. It's on the YouTube channel, and it's a really exciting tutorial if you want to watch it. Anyways, now just like the Gotham filter, there is another exciting filter which requires you to change some channels a bit, and it's called the Sepia filter. So this sort of looks like this. You take an image like this and it converts it into something like this. Now this gives you, I think, the old vintage look, sort of like vintage look, and you might want this for some images. It might look like pretty cool for some particular scenarios. Now I don't use this a lot, but I think many people have seen like use this sort of an effect. Now to do this, there are 2 ways to go about it. Now the formula for converting the image into sepia is something like this. You split the image into the 3 channels, and then you change each channels by something like this. So these are the numbers I got from the internet on how to create the sepia filter. So the red channel, you change the blue channel to be a mix of all the 3 channels, and then you multiply the pixel values by these fractions. So this is how you change the blue channel, and these are the numbers you need to make the necessary multiplications to change the green channel, and these are the numbers for the red channel. Again, these are just some values to get an effect like this. You may want to slightly change it to get a different sort of an effect, and you just change the values here. It's up to you what sort of effect you're looking for. But to get the sepia standard filter like you see in Instagram, you need to use some values like these. After you're done changing the 3 channels, you'll merge it back just like we've been doing all along, and then we'll just convert it back to NumPy array with unsigned date values. We'll also clip all values above 255 so that it doesn't rolls back. So there's a rollback functionality where all the values above 255 rolls back and starts again from 0, and you'll see some artifacts if you don't clip out the values above 255. So you need to clip out the values above 255, then convert it back to a NumPy array, and then just display the results. So after initializing that, so looks pretty nice. Let's test it out on another image. So this is what it looks like. Again, I think it's a really cool filter that you can use. By the way, there's one other way that you can do this. So instead of just manually taking the channel, multiplying it with the constant value like this, you can just create a sepia matrix like this with all these values and just multiply it like this. So if I do this, this will also work and give you the same exact filter. And this is like a shorthand way to do this. The other way to go about it is to do this, but it's up to you which approach you prefer. So I think this was like a bit more intuitive if you're not sure how matrices work. So that's why I just displayed how this is done manually. But if you're comfortable using with matrices, just do this. And by doing this, this is much easier and simpler to experiment with different variations of the same effect, I think. So that is all you need to do to create this sepia filter. Now let's move on to another filter, and this is the pencil sketch filter. So this is what you're looking at. You take an image and you apply some pencil sketch, filter to it, and you get this back. Obviously, this is not as good as you might have seen some amazing pencil sketch filters by the artists out there, and but this is what you get if you're looking to create a pencil sketch filter by just using image processing. Remember, we're not even using some deep learning techniques. Now, I'm really sure that there are some amazing deep learning models out there that maybe creates some realistic looking pencil sketch filters with like that are very pleasing to the eye and have a nice fidelity to it. But if you're just gonna use some image processing techniques to create sort of a pencil sketch effect, this is the best probably you get by using the function called cv.pencilsketch in OpenCV. And so this is the function that we'll be using, cv2.pencilsketch, and it takes a couple of variables. We have like sigma s, sigma r, and shade factor. The shade factor controls the intensity, how bright the final output looks like. Then we have this sigma s and sigma r. Now the definitions of these two variables, I've explained them in a lot more detail in my image processing and computer vision 3-month course. And it's a bit out of scope to go into the detail of how these working, and it would be a lot more like easier if you know how image filters generally work and like smoothing techniques and how all of these work. But just like as a short recap, I'll just say that sigma s controls the filter size. So the intention of these filters, so the pencil sketch belongs to the family of like edge aware filter. So the intention here is to pop out the edges, make them visible, and smooth out all the constant areas in the image. So all the areas which have a constant color, you just smooth them out, or you blur them out, sort of like that, and then you make the edges pop, you make the edges more visible. So this is why this belongs to the family of like the edge aware filters. And when you're using something like that, what you want, the control that you have is the control of the filter size. So you can increase the filter size and you'll see sort of like a different effect. And then the other control you have is how much color difference you're willing to sacrifice. So by controlling these two values, you'll see different sort of variations in the final effect that you create. One other thing, when you use this function, it actually gives you two outputs. So one is the grayscale sketch and the other is a color sketch. Right now what you're seeing here is a color sketch. So you take an image and you provided a colored filled pencil sketch, but you can get a black and white or a grayscale effect or a grayscale color effect by just displaying this. You don't have to do any other additional thing. By default you get both of these sketches, but right now I'm just going to display the color sketch because I think it's much more nicer than the grayscale sketch. But anyways, you can feel free to display this with Matplotlib if you want. But right now, as you can see, I'm just going to display the color sketch, and I'm going to ignore the grayscale sketch. But again, you can display this if you want, and it's also a bit nice. But yeah, so all I'm doing is taking the image, passing it into the pencil sketch function, setting the sigma value as 20, sigma r, which controls how much you're willing to differentiate between the edges and the constant color, to 0.5. The range of these values is from 0 to 200 for sigma s, and sigma r is 0 to 1, I think. Yeah. Again, to explain in detail what exactly these values are, it's out of the scope of this tutorial, but I've tried my best to just explain it in a minute or so. So anyways, moving on, let's apply it to some images and see the results. Input image like this, and we get the I guess maybe an amateur pencil sketch artist would create something like this. So it's nice, it would pass for that standards. Let's apply it to another image, and yeah, I don't think this is not a nice effect for me. Let maybe see what sort of the grayscale effect of this particular image looks like. So what I'm just going to do is I'm just going to set this gray, call it gray image, and then maybe I'll just show all three images just for the sake of this tutorial. And okay, this image, So because this is a single channel image, I guess I have to pass the C map equals to gray, right? So this should work, I suppose. All right, so what we did here is, oh yeah, all right. All right, so yeah, input image, the output image, and the clear sketch. So it's not bad. It's not bad. Okay, so next one. Yeah, this one is pretty bad. I think I need to adjust the values to again. These values are tunable. What you can do is just add these values as hyperparameters above here, so that for each individual image you can adjust the sigmas and the sigma r values and the shape factor values. So you can make all these three hyperparameters. Alright, so this was the pencil sketch filter, and let's move on to another filter, the sharpening filter, which exactly does as the name says. It sharpens the image to something like this. You take this sort of an original image and you sharpen all the edges, all the corners, and all the like line areas, and this is what it looks like. And it's actually pretty simple. All you do is create a kernel and just make it pass over the whole image. So it's just a convolution operation where you take a filter and a kernel, then make it like multiply with pixel values all over the image. So this is the filter that we're gonna create, and this is called the sharpening kernel. And every time you like you see this, you can see that this is sort of like a filter that sharpens the vertical edges and the horizontal edges. They are if you know much about image processing, and I've covered this again in my image processing course, is that you can create different sorts of filters, like filters that enhance the x-axis, the edges in the x-axis, filters that enhance the edges in the y-axis, filters that smoothes or the blurs out the whole image, and creates filters that create all sorts of other effects. And it's pretty exciting that even before I show you the output, if I just show you the kernel and you know the basics, you can tell me exactly what this filter is going to do. So this is how good the theory behind these filters are. So anyways, this filter is going to sharpen all the edges in the image. So I've created the filter here, and then I'm going to use OpenCV's function called filter 2D, which is going to take a kernel or a filter and make it pass all over the image. So it takes a source image, you pass in the source image, and then you pass in the kernel that you've created above. So this is like a 3x3 kernel, and you can increase the sharpness effect by just messing around with these values. Yeah, so it will increase or decrease, like how much sharp the effect you will see. So anyways, once you're done, you get the output image back, and we're just going to display it here. So now that function is initialized, let's test it out on some images. So we take this original image and we sharpen it. As you can see, this is much more crisper and a lot more sharper than the original one. Again, for this image, we get this sort of feedback back. So again, much sharper and much crisp results compared to the original. So yeah, all right. Now moving on to another very similar filter that does about the same thing, but it gives you a lot more control. So this filter is called a detail enhancing filter. It belongs to the same family of the pencil sketch filter, because you're going to use the same variables here. So this is the function name that you're going to use. You're going to pass in the image. It accepts the same two variables, sigma s and sigma r, that you use in the pencil sketch filter. So it belongs to the same edge enhancement filter, and it's gonna take this image and apply the effect, and you're gonna get this sort of result back. As you can see, it not only it enhances the edges, but all the color distribution is a lot more richer and much nice. So this is like a more fine-grained control over how sharp and how the final output looks like. So you can try this out if you want more control over how the final output looks like compared to just running the kernel over the image. So I'm just gonna run this, and then I'm gonna check it out on a couple of images. So this is how this looks like. You take this image, and you can notice the texture is a lot more richer. All right. So let's test it out on another image. So yeah, the whole image, pops out. The contents are a lot nicer, and it's much more pleasing to the eye. Like you take this original image and then you see this. This is a lot more nicer compared to this. And again, you can change these values, experiment with it, and get different variations out of the same effect. So yeah, and definitely do experiment after downloading this notebook. All right, now I think I'm gonna try out one of my favorite filters, which I love since like the beginning. So I always sort of liked, and the interesting thing is it's one of the simplest filters that you can think of, the inverted filter. You just take the pixels and invert the values. You can do this in multiple ways. So the easiest way to go about it would be just take the pixel values and subtract 255 out of it. So you get and then take the absolute values of the final result, and you'll get an image where all the pixels values will be flipped, sort of like that. White will be black, and all the color channels will be sort of like values will be reversed. So something like that you'll get. And maybe if you've seen negatives of the images in the previous generation cameras, you might have seen something like this. And I sort of like love this effect because it's I think a pretty cool effect that you can create. So out of all of the filters, I think this is one of the filters that you can have the most fun with. So the way to apply this filter is, like I guess, multiple ways to do this, but I'll use OpenCV's CV2 bitwise not function, which will invert all the values. So, and this is just a single line of code. So I'll take the image, pass it to the CV2 bitwise not. It will invert all the values, and I'll get the final output back. And this is all I need to do to get this effect. And it's just a simple mathematical operation, bitwise not, that I'm applying here, and then I'm displaying the final results. Let's check it out. So I've initialized the function. Now let's test it out on some images. So, this looks a bit scary, I guess. Not the best look for this girl, but let's check it out on another image. So yeah, I think this is sort of like a cool end of the world apocalyptic effect for this particular image. Let's test it out on another image. So yeah, I think this is one of the best ones. Maybe this volcanic sort of like, I think this is also ice, but like this looks like a much I don't know how to describe this one, but like as you can see, pretty nice effect in some scenarios. And yeah, now I think this is the final filter, right? Before we move on to the real-time webcam feed, yeah, this is the final one, the stylization effect. Now this, if you're looking for a filter that gives you sort of like a cartoonish look, if take an image, convert it into some sort of cool looking cartoons, this is the filter that you need. This takes an image and smoothes out all the constant color areas and pops out the edges. And this filter also belongs to the same family of the pencil sketch filter and the detail enhancing filter. So it takes in the same variables, so sigma s and sigma r, and again, depending upon what values you pass, the effect will be different. So all we need to do is pass the input image into this function, and this is the name cv.stylization, and you get the output image back. That's all. In this single line of code, we're going to transform the image and apply this cartoonish look. So that is what I think the best describes this filter, cartoonish sort of a look. So after we're done, we get the output image and display it with matplotlib. Let's check it out. All right, let's test it out with this image, and it's loading up. So this is the input image, and this is how the final output looks like. You can again change how the final output looks like and make it look more cartoonish, change the values. Let's do it on another image, and yeah, it's sort of a good look for this image. Yeah, so this is the stylization filter in action. Now let's move on to the real-time webcam application, where we'll apply all the filters and in real time on the webcam feed. Now some filters are computationally more expensive, and you will see when I run this, you'll see some filters like destroy the FPS. So what I'll do in this application is I'll display all the filters selection boxes on top of the webcam feed, and then I'll make the mouse click select each individual filters, and then that filter will be applied in real time to the final webcam feed. So that's what you will see. So the first thing I'll do is create this mouse callback function, which will and I'll specify different areas. Now this is something I've already done in the previous tutorial, so make sure to watch it to fully understand what sort of thing I'm doing. But let me briefly recap what's happening here. This is a mouse callback function that you need to create in order to use mouse clicks inside the OpenCV's window. And inside of this function, what I'm going to do is create different sections. So these are all the sections that I'm creating. So these are like different parts of the screen or the image feed in the whole webcam. So let me just expand this. So if you're seeing something like this, then I'm going to take the top of this screen, and if I move the mouse and click here, then maybe the grayscale filter will be used. If I move the mouse and click maybe on this side of the screen, maybe a sepia filter will be used. So similarly for here, I'll probably use the Gotham filter. This will be the normal feed, and then again I'll select 10 different sections of the screen, top like boxes, ROIs, and if I move my mouse in that particular location and click on it, then that filter will be activated. So this is the intention of this particular application. So that is why I'm creating if and else conditions and specifying different parts of the screen depending upon the width and the height, and assigning it to a particular filter. So this section of the screen is particularly allocated to the cold filter. This section is for the warm filter. So just assigning sections of the screen to filters, and that is all I'm doing here. Now I'll create another function, and this function is responsible for applying the appropriate filter depending upon which section I clicked. So if I clicked on the warm, then the warm filter should be applied. So if filter applied is warm, then apply the warm filter. If filter applied is cold, apply the cold filter. If filter applies Gotham, apply the Gotham filter. And similarly, you just apply all the remaining filters. So that is all this function does. Now comes the final script. Now this is the final script of the whole tutorial here. Let me just go over this and just go back here. Now all it's doing is just using the functions that we created above inside of it. So we start off by initializing the camera, then we attach the mouse callback to this image window that we need to create in order to use the mouse callback. Then initially the filter applied should be normal when we launch the whole application, and then I'm just initializing the Pygame library in order to use this camera sound. So there will be a camera icon at the bottom, and when I click it, there will be camera sound. So that is why I'll be using the Pygame library. It's completely optional if you want to create that camera sound. It's cool, that's why I included it. So I also have this functionality where I click on the camera icon and an image will be taken and it will be displayed with matplotlib at the bottom, and it will also be saved in your current directory. Alright, so that is why the camera image variable will control if I'm going to take an image or not. And then we have this camera icon too. So we're going to start off by opening up the camera. We're going to read frame by frame. We're going to make sure everything is okay, get the width and height, flip the frame laterally so I see a mirror view of myself. And if none of the filters are applied, we're going to create a dictionary where the name of each filter name is whenever it's the key of that is used, we call the applied detail, we call the appropriate filter and apply it. Right. So after that is done, what we do is that, so this is so this is the area where we remember I told you that I'm assigning different parts of the screen to particular filters. So this is just for visual purposes, where I took those parts of the screen and create a border out of it. So whenever I click on the appropriate screen filter, there will be a white border drawn out of it. So it's clear that which filter is selected at the moment. So the selected filter will have a border. I think it's a white border or green border. I'll see this later on, which border color is used. So I think it's probably white, or so we'll be using. So yeah, all other filters will be white, but the selected filter will be green. I think I'll see this later on. And then we'll just resize the filter and display it in that particular window. You'll see what's happening after, like I launched this whole application. So what I'm doing is taking the whole frame, resizing it into this small size, and then just putting it here and drawing a border around it. And so if I move around, the whole small boxes, all those boxes, will be moving along with me, so that you see the preview of the effects in action. So anyways, moving on. So now what I'm going to do is that I have this sort of code. So this code is particularly responsible for making sure when I click on the camera icon, it takes an image, it displays the result with matplotlib below, and it saves the image in the current directory. So it uses cv to imwrite function to save that image as captured image.png, and then it also for a brief moment it displays this zeros image to make that snap effect. So this is just for visual purposes. It will be a quick effect that you'll see, and again for visual purposes you'll see a sound of an image being taken. And then yeah, so that's it. We'll just display the image matplotlib below. And so yeah, so this is just for reading the camera icon and displaying the camera icon on top and bottom. So the camera icon has the alpha channel. It's a transparent image. Whenever you using transparent images, you want to utilize the alpha channel, and you pass in this particular flag. Again, this all relates to some more knowledge in OpenCV, what sort of options we have. So you might know we have a color image which has 3 channels, RGB. You might know that we have a black and white or grayscale, which has a single channel. And there's another popular category where we have 4 channels, and the 4th channel is called the alpha channel, which controls the transparency of the image. So the camera icon that's going to be displayed at the bottom is a transparent image. That's why I'm reading it in the alpha channel, and I'm resizing it properly, getting the required width and height, and then putting it on the appropriate place in the ROI frame. So that is all that we're going to do. And so yeah, that's just for displaying the camera feed. So once that is done, the final thing that we need to do is put those frame windows. So these are all the frames. So one frame area is responsible for the Gotham filter, the Sepia filter, the normal filters. So initially what I did above here is, as you might recall, is that I allocated areas, but I didn't annotate the whole screen, right? I just allocated areas, ROIs. This ROI is responsible for controlling the inverted filter. This area is will be allocated to the sharpening filter, but I didn't draw anything on the screen. I didn't put anything here. That is what I'm doing in this part of the code. In this part, I'm actually putting that areas here. I also initially went over this where I draw out the borders, but this is where I actually put those frames on different parts of the whole video feed. So it's all there. Finally, I show the whole final results with cv.imshow, and if the person presses the escape key, we exit out. We clear up the camera, we destroy all the windows. So that is all what's happening. And let's test out the final application. So yeah, and I think the window, yeah. So this is what this looks like. And so as you can see, I have these small window tabs here, and all of them are fixed here. And if I select this filter or this sepia effect, I think this is the sepia one that's working in real time, approximately in real time, not to apply the grayscale filter. This is because this is a very simple effect. You don't see any lag here. Now remember, all of this is running on a CPU, and I'm also recording at the same time. So that is also taking up some computation. And after that recording, this is the OpenCV processing that's taking up space. So maybe if you're not recording like me, this will be somewhat faster, depending if you're running on a decent CPU. So I think yeah, this is another filter. I think I should probably put names here. Not this is probably the cold effect. This should be the warm effect. Yeah. So this is the warm effect. And this one, I don't exactly remember what this one is. Maybe the detail enhancing. All right. So, and yeah, all right. So this is the normal one, right? And this is a very computationally expensive filter, and this is, as you can guess, the pencil sketch colored filter. And this is the, I think, the detail enhancing or the sharpening filter. And yeah, this is one of my, I guess, told you the favorite one, the inverted filter, right? So I think this is one of the coolest ones. And so yeah, I think this is the detail enhancing filter, and this is like the sharpening filter. So that's why the difference in quality. And finally, this one is the stylization filter. So yeah, pretty cartoonish looks that we're getting right now. One other thing that you can do, by the way, is like create a track bar. So in my previous tutorial, I created track bars where I controlled like intensities of the filter effects. Now because all of these filter effects does not require controlling the same parameters, they all have sort of like different parameters and effects. So that's why creating a track bar, a standard track bar for all of these was a challenging task. I obviously had to do a lot of coding in order to create such a track bar such that it affects all of the filters. So, but for specific filters, you can create track bars that, for example, sigma S and sigma R is being used on multiple filters. So you can create a track bar that controls the sigma S and sigma R values, so that you can see the changes in and all the variations in real time as you test all of this out. So and finally, let me show you this the camera icon, the camera effect. So as soon as I click this, an image is taken, and you see this black screen appear. This is again just for visual purposes to make it look nice. So again, and yeah, to make this camera sound and give this effect. So this is the whole application, and the final part of our Instagram tutorial. And yeah, that is all. By the way, again, if you go over all of these 3 tutorials, how the first one was how to use the mouse and the trackbar. The second one was how to work with lookup tables and how to create different color effects and how to work with advanced color effects. And this third one where we use 10 different exciting filters. So if you've gone over all of this, you have a very detailed and understanding of how different filters are created, and maybe you can create your own application like Instagram, not the whole application, but like the filters part, and an application that applies some sort of unique filters, and maybe you can attach this functionality to your existing applications. All of this was done in Python, but the same thing as OpenCV has bindings for Java and for iOS, so can be done in for mobile applications or web application. OpenCV has bindings for .js. So all of this, once you've understood it, you can create web applications or mobile applications out of this whole thing. I hope that all of this whole series was informative and exciting for you. If you found it useful, make sure to subscribe to this channel and like this video, maybe share it with your colleagues, and let me know in the comments how you find this experience. And more exciting tutorials are coming to Bleed AI, so stay tuned for that. And I'll see you in the next one. Bye.